Okay, so welcome back. Today we're going to go through the third of the lab sheets that are available for this module. And it is one of the most important ones because essentially in this lab sheet we will be building our first virtual machine in the cloud. All right, so the main purpose of having a cloud is to have computers running in a virtual environment that you can provide access to people all around the world so that they can use them. More importantly, these virtual computers, these virtual machines need to be built for purpose. So they need to be built in a way that they can serve your business's needs. All right. And the configuration that we'll choose to do to perform for each of these virtual machines needs to be very specific and needs to have like a purpose in life, as we call it. Now, the whole story about building a virtual machine is that it's pretty much like a pyramid. So there are components that virtual machines depend on, and they need to be configured in a very specific way, in a specific order. Otherwise, you won't have the available items that you need in order to build everything. So to make a start, so the first thing that you need to do is you need to configure network infrastructure. You then need to configure a host. So you need to have a virtual machine. You need to have a host that can run virtual machines inside your cloud. You need to have your data stores in place. So you need to have a place where you have hard drive space that you can use for your images for your virtual machines. You then have your images themselves, so they will be either blank hard drives or hard drives built with the operating system, or even DVD ISO images of the operating system that you want to install and so on. You will then need to have a template or multiple templates, and that template will essentially be the recipe that you will use in order to build your virtual machine. So it will tell you, how many CPU cores you have, how much RAM, which images to use for hard drives, what networking infrastructure, and so on. And then finally, you can, using that template that uses the images, that uses the networking and the data stores and the host, you can start up a virtual machine and run it in your cloud. So let's look at everything one by one. First of all, the networking infrastructure. So your cloud needs to exist somewhere where the networking infrastructure allows for two things. One is for communication of the cloud and all of its individual components, like the virtual machines and everything, with the outside world. And two, you need to be able to have communication between all of the necessary components of the cloud itself, so that they can communicate with each other. So for example, the front end needs to be able to communicate with the virtualization host so that they can run all of the background daemons that monitor the cloud itself and help you run the cloud itself. So in our case, we will need to make a couple of small changes to our virtual machines in order to have the networking that we need to have. So we generally prefer a bridged type of networking between the outside world, because then we can bridge other interfaces onto that as well, and in this way give access to our virtual machines on the inside to outside of your host as well. So the first thing that we'll need to do is we'll need to take your default network card. That's 99% of the times it's called ENS 160 on your host, and we'll need to change it. So we'll need to configure a network interface that's called BR0, so bridge 0. In order to do this, the first thing that I want you to do is I want you to yum install network scripts. So that installs some legacy network scripts that I like using. You can do without it if you like. But I like using them still, and it's good for you to know them as well, because you might have to work on a system that's relatively older and you might need to know these commands as well. So once you install the network scripts, you can then go about editing the files. In Linux, your network cards are controlled by the configuration files that start with ifcfg net something, and they exist in etc. sysconfig network scripts. Okay. You might have a graphical user interface on the top right corner of your GUI, of your desktop manager, that you configure network cards there, so you can have the IP addresses and everything there. However, all that does is it writes information in these configuration files. All right, so it's those configuration files and them being read correctly by the operating system that actually run the networking onto your operating system. So what we'll do is we'll make changes to those network cards. So first of all, we will go to the IFCFG NS160, And what I want you to do from there is wipe out its contents completely and replace them with those lines in here. Essentially, we're telling the ENS160 network card, look, you are now part of a bridge. Your bridge device is BR0. You don't need any networking. You're called ENS160, yes. You don't need to start when the machine boots up. You don't need to be controlled by the network manager, so you will not show up on the GUI on the top right corner. Okay, you can start as a device when the machine starts. You are of type Ethernet and you are bridged to BR0. All right, this is what this file does. Once you do this and you run this gedit command, the gedit command has the wonderful skill that you can create a file out of nothing. All right, so once you type the command, this BR0 file doesn't actually exist. It will create a new file, name it as it is, and open it for editing. You'll need to copy and paste the contents of this gray box into that file. Obviously, remove the red letters and everything, yes? And this IP address will be whatever your ENS160 IP address was. So it will be whatever is on the monitor, on the little blue sticker that you have on your monitor, plus 50. So it will be your Prometheus IP address. All right. Prefix, gateway, DNS, domain, everything else is the same as it's always been, so nothing changes. The network information itself is the same. And then you tell it to start on boot, and you tell it that it has to have a static IP address when it starts, and again, it's not controlled by the network manager. So once you do this and you restart your network, the network manager, so the GUI on the desktop manager, will not actually have access to these network cards, and that's okay. Okay. You restart the network service, and then you enable it so that you make sure that it always runs when you start up your computer. So then the result of all of this will be that your ENS160 network card will run, but it will not have an IP address, and you will have a new BR0 network card that will run and will have the IP address of whatever your ENS160 was before. Okay, you can see all of this if you type ifconfig in a terminal window. All right. So once it's completed, we can move on to the next part of what we need to do. We need to hack the operating system a little bit, just a little bit. All right. So you need to find this file called OpenNebula Network Conf, and in there you need to search for the parameter that's called keep empty bridge and change it from false to true. This is because when you build your virtual machine in OpenNebula, if you shut it down, it will shut down the bridge as well. Okay, and this is a sort of glitch or idiosyncrasy of the operating system itself, if you like, because it sees that a network card is being shut down by the cloud itself, so the operating system shuts down the network card as well. Okay, we don't want to do this. Okay, we don't want OpenNebula to be telling the operating system or to be showing the operating system that the network card has shut down. So if we change this value and then we SU1 admin and force it to sync, that will sync the OpenNebula server with our operating system, and then they will not listen to each other about this particular command. Okay, so they will not sync the network cards. Once you've sorted out the networking aspect of it, we can start with the rest of the requirements. So we can add a host. This means that we can add a host into our cloud that can start and run virtual machines by itself. So we go to infrastructure, we go to hosts, and in there you need what we call the fully qualified domain name of your computer. The easiest way to do this is to open a terminal and just type hostname. Whatever comes back from there, copy it and paste it and put it in OpenNebula. This should say init, and then eventually it should turn to on. If it doesn't turn to on, then there's two things that can go wrong. Either the host name is not actually correct, so you have a typo or you misspell it. I don't like capital letters in host names generally. Okay, so if you have it, maybe change it and restart the virtual machine and try it again. Or you have a problem with your passwordless SSH from the previous lab sheet. Okay, maybe there's a typo in it or something. Either way, you need to let us know in the lab call us and we'll come and try and figure it out and sort it out for you. Okay. Once the host is on, then you have it and it's ready to run virtual machines. The next item on the list is the data stores. You should have 3 data stores by default in your OpenNebula Sandstone. They should be there. You should have image, system, and files. Just go and check that all 3 of them are there, and that's enough. You don't need to actually do anything about this. We then add our network infrastructure into the cloud itself. So our new bridge is giving us a way out of the virtual machine or of your virtualization server to the outside world. We need to be able to connect our virtual machines that we're building inside the cloud to that bridge as well, so that our virtual machines can get access to the outside world. What we need to do is we need to go to networks, virtual networks, add a bridge, name it BR0. Basically just follow the instructions there, give the networking infrastructure that it needs to have, and the only thing that you need to be careful about here is the IP address. The I and the P seem to have had a fight on this. So, alright, I'll fix this. So the IP address is what you need to be careful about. We are bridging the new virtual machine that we're building inside our cloud. So at the moment we have our host computer with, let's say, an IP address of 28.1. We have our Prometheus, which is bridged once and has a 28.51 IP address. The new virtual machine that you will build, that you will be called vPrometheus 0 and will live inside the cloud, that lives inside Prometheus, that lives inside your host. Yeah, nested virtualization, will need to be bridged once more. So we add another 50 to that address. So this virtual machine can have an IP address of 28.101. Okay, so this is what the IP address needs to be for your virtual machine. This is happening in the settings of the cloud. It's because the cloud needs to know what IP address all of the clients inside it, all of the VMs inside it need to have. Because this will be a network card that we will configure and we will assign this network card to the virtual machine that we're building. So it needs to have the correct properties. Once we sort out the networking, we can deal with the images. So now we need 2 images for our operating system to be built. We need one image which will be the hard drive, and we'll need one image which will be essentially the DVD for the installation, okay, or the USB stick for the installation. So the first thing that you need to do is you need to go into the settings of this, and before you actually deal with any of this, you need to make sure that you have a copy of the Rocky ISO image inside Prometheus. At the moment, you only have a copy of this ISO image on your host operating system. Yeah, so this is the one that you used in order to build Prometheus itself. It's located in your home, in your global directory. You will need to copy the image from there onto the virtual machine, onto Prometheus. You are master students, I shouldn't have to tell you how to do this, but I will anyway. So the command is scp, so secure copy. Okay, so you need scp space, and then the name of the image, Rocky whatever .iso, and then space root at and the IP address of your virtual machine, and then a colon next to it. All right, I will show you the command in the lab as well, and in all probability I will add the command in this lab sheet too. All right, but the format of the command is just like any other copy command. So it's copy source to destination. So scp, the source is the ISO image file, and the destination is you logging in as user root at computer, whatever the IP address of your virtual machine is, and that's it. So once you've done the copy and you have the ISO image inside Prometheus itself, you can then add it onto OpenNebula. So you can upload it onto the OpenNebula server itself. Now this in itself is very annoying with Rocky 8. It used to work in CentOS 7, and now for some reason it doesn't really. So theoretically you have 2 options to do this. You can either upload the ISO image straight up by using upload, or you could do upload from a web address. So you could actually go to Rocky's website and input a URL from there into a box and just click upload, and it should be able to download it from the internet. None of them work. We don't know why. Okay, I've spent countless hours last semester trying to figure this out, and then in the end we figured out a workaround to this. All right, so we can start our own web server because we have Python installed in our systems. Okay, so with this simple command of python 3 -m http.server, you are starting a rudimentary web server onto your system itself. Okay. When you type this command, just make sure that in the terminal that you're typing it in, you're in the same folder as this terminal has two R's. There's some typos in the slabs, I'll fix them. So when you're typing this command, make sure that you are in the same directory as the file itself. Okay, so it will be in your home folder. Make sure you are in your home folder when you type this. So when you're starting this web server, if you go to HTTP localhost port 8000, that will give you a listing of the folder in which you're running this server. All you need to do then is right click on the Rocky ISO image there and just choose copy URL, and essentially you're downloading the image onto your computer from a web server that's running onto your computer. It is what it is. If you find a better way to do this, I will give you an extra 5 marks. Yes, good. So that's done. It will take a while, and once it's finished, the image will show up as ready. Okay, and it means that you can use it, and you can move on even while it's still uploading, and you can create a second image, which will be the blank hard drive that we will use for our virtual machines. Okay, so we call the image vPrometheus 0, it will be a generic storage block, you make it persistent, you set it to type empty disk image, you give it 20 gigabytes of space, and you set the format in the advanced option, so you need to scroll down a little bit for this, and set it to QCOW2. So QCOW2 is the file system that we'll use. We're going to give it 20 gigabytes of space because we're not really going to do much with it, so we don't need too much space. And we're going to make it persistent. So this is important. Why? So the images that we can have, the same as the templates that we can have inside OpenNebula, they can be persistent or no persistent. It means that if they are persistent, anything that we write onto them stays onto them forever. Even after we've shut down the operating system of the virtual machine in the cloud, even if we've removed the virtual machine from the cloud, all of the contents that we've written onto this image will stay on this image. All right. You can have non-persistent images, so they have to be non-operating system disks. Okay, so you make the operating system disk persistent because you're installing the operating system onto it, and you want everything to stay there. But you can make virtual machines in the cloud that have a second image that is just a hard drive space that's available for whatever use your users are using it for, and it can be non-persistent. So when you stop the virtual machine from running, it wipes out, and then the next user has a blank hard drive to work with. Okay, so in our case, we need to make it persistent because we're building an operating system onto it, and it needs to stay like that. So now that we have all of our components, we can create our template. The template is essentially the guide that tells the OpenNebula what the virtual machine will consist of. Okay, so we want to start a virtual machine. We're going to call it VP0. The hypervisor type will be KVM instead of VMware or anything else. Okay, KVM is the native hypervisor for Red Hat operating systems, and OpenNebula supports this as its favorite. We're going to give 4 gigabytes of RAM to the new virtual machine that we're building in the cloud. We will enable hot resize, so we will allow the users to be able to change the amount of memory onto the system, okay, even when the virtual machine is running. Scary. You'll do this in the next lab. So, physical CPU is 1, virtual CPU 1, so we'll keep it as simple as possible. Again, allow it to hot resize. And then we'll go to storage tab. We'll give it 2 hard drives, so we'll give it 0 and 1. One will be the image of the operating system, the other one will be the ISO of the DVD. You need to be very careful that they are selected so that they can actually start from them. Okay, because when you first build the virtual machine, it will need to start from the DVD, but then after it restarts, it needs to choose to start from the hard drive first. So the boot order should be hard drive, then DVD. Yeah. In the network tab, you choose bridge. So you select the bridge network card for it, and then in the input-output, you can select VNC because that's how you actually connect onto the virtual machine. That's the mechanism behind it. All right, and you create the template. Once you've created the template, you can now start it as a virtual machine, and as we nerds call it, you can instantiate it in the cloud. All right, so you can click on instantiate, and it will start up a virtual machine. You can connect to it via VNC, so there will be a little blue icon inside OpenNebula. It will open a new tab on your browser, and you will see a live image of the virtual machine actually running, and you have to do the installation of the operating system. So you can just install it as a GNOME desktop. I think it's probably called Workstation, or whatever it's called now. IP address should be the IP address that we've used on the second bridge. Okay, so plus 100 from what's on your screen. And root, localhost 1, everything is the same as all of the machines that we've built so far. Okay, so once you complete the installation of the operating system onto it, then you will have a virtual machine that's running inside your cloud. Okay, the most important aspect of this is that they all depend on another. You cannot go start building a template unless you have the required network cards, you have the required images, and they live on the data stores that are available for them to start, and so on and so forth. When the virtual machine starts, when you click on instantiate, it will show up on the OpenNebula as a running virtual machine, but until it shows up as a running virtual machine, it first has to get an IP address. So it will show the IP address it gets from OpenNebula. It will then also need to be allocated to a host. So it will need to be allocated to a virtualization host so that it can actually run. Okay, and these are all steps in which things can go wrong. Okay, so once it does all of this, it will say boot, and then it will say on, and the little blue icon will show up, and then you can all, rejoice because the thing is working. All right, so follow the steps slowly and carefully. Make sure you take screenshots of everything because it's important. It's more important than the logbook being marked because you get to figure out if you made a mistake somewhere. So if you forget, for example, one of those persistent boxes to be checked, you'll have problems later on. As soon as you deinstantiate and instantiate the virtual machine again, there will be nothing there. Okay. Now, on Moodle itself, I've uploaded all of the lab sheets. Okay, so you can actually go on to the next, to the following weeks and so on. We have VM creation, which is for next week, essentially. We have the Sandstone familiarization lab sheet, which is the next one. Then we have the networking, and then we have the populating the cloud, and that's it. Okay, the populating the cloud is the last lab sheet that I will give you, and that leaves you with 1, 2, 3, 4 weeks to do it. Okay, it's big because you have to build a bunch of virtual machines, connect them and make them work with each other and so on. But that's the whole idea. The idea is that you learn how to build and manage your own cloud, okay? And everything else that we do before that is just essentially the prerequisite knowledge that you need to have in order for you to be able to do this, okay? In the last week is assessment week, so the logbooks, so that will be Friday the 16th of May, and I have the instructions here as well on how the logbooks will be marked. All right, and of course we have the 3 weeks of Easter break, and we have the consolidation week as well. Ideally, I don't care about you keeping the timeline of these. Even if you go slower or if you go faster, I don't mind. You can go back to the lab today and finish all the lab sheets if you can. However, if you move on to lab sheets that I haven't explained in the lectures, there might be some details that you might be missing and you're struggling for nothing. Or more importantly, taking away time from the lab assistants to help you with something that hasn't been explained to you in the labs, in the lecture, instead of them being, helping somebody else. Okay, so if you do decide to venture forward from what I have delivered in the lab sheets, okay, please try really hard to troubleshoot whatever problem you have yourself before asking for help from us in the lab. Okay, and most importantly, backups. Make sure you take a backup of your virtual machine. I've already had 2 students today use their backups from last week. Okay, things can go wrong. That's why we're working in a virtual machine, and that's why we're nesting the VMs in the cloud, so that you can restore backups and you can not waste time and have to start all over again. Okay, so that's it. Any questions about the virtual machine build? All right, yes?
Sorry, is there a limitation number of the hosts to add in the open?
Right, so the limitation only comes down to the resources available. So we have 400 gigabytes of space. In the past, I used to have 200 gigabytes of space, so people would run out. And you also need to think about the fact that every time you run a virtual machine, so when you instantiate a virtual machine, the images that you're using are being copied from one data store onto another. Okay, so if your virtual machine has an image that's 20 gigabytes and your operating system DVD ISO image is another 15 gigabytes, that's 35 gigabytes, doubled, it's 70. Okay, so you need to be wary about that. And then of course, it's the number of CPU cores and the number of memory available in the system. So the 8 gigs that we have on Prometheus and the 32 gigabytes of RAM, the 8 cores, sorry, and the 30 gigabytes of RAM are really your limit. So essentially, you should be able to build 8 virtual machines with 1 core each and run them in there, and 4 gigabytes of RAM. Okay. Anything else? All right, thank you very much.